Hi guys, Mrs. Duqua. It's Core 4, May 6th. We're going to be looking at complex numbers and DeMoivre's theorem. They're super cool. Alrighty, let's go. Here's my thing for today. Did you get it? You so should totally get it. Equals Cosby, get it? Cosby. Alright. Anyway, for today we're going to be needing our table for working problems of DeMoivre's theorem and all that good stuff. Alrighty. Okay, so we have an imaginary axis and we have a real axis. This is really cool, by the way. So these are real numbers. Here's our imaginary line. Because our complex numbers look like a plus bi. So if I had 2 plus 3i, what you would do is you simply go over 2 on the real axis, and then you're going to go up 3. 1, 2, 3. There's our point. Anyway, so also when we have the absolute value of a complex number for a plus bi, we're just going to take a, square it, b, square it, and find the square root of it. That's it. All right, so let's graph and then let's find the absolute value. So we're going to do 1b or 1a. So if we're going to graph this, let's go ahead, create our, oh, I missed it. Got it on that one. So these are real, these are our imaginaries. So if we're going to go over 5, 1, 2, 3, 4, 5, then up to 1, 2. There it is. And then if we want to find its absolute value, we're going to take square root 5 squared plus 4 squared. So the absolute value of that complex number is the square root of 29. Cool. Oh yeah, forgot. Let's rework this one in terms of the next problem. So this next problem, oh, we still have that one. That's cool. This is my real plane. This is my imaginary plane. So let's go plot that point. We're not doing that one. We're doing B. 1, 2, 3, up 4, 1, 2, 3, 4. Okay, let's calculate. Ooh, it didn't show up. 1, 2, 3. 1, 2, 3, 4. There's our point. Let's do the absolute value of z. That equals the square root of negative 3 squared, which is going to be 9 plus 4 squared. Square root 9 plus 16. Square root 25. Answer 5. Alrighty, there we go. Okay, so pause and read this stuff. Key part is for a greater than 0 or a less than 0. And we have to determine where our tangent is, okay? And then in order to find r, and we'll work these, okay? But they're all coming from here. Okay. All those parts, memorize them. So we want to express the complex number in polar form, and what that means is we want it to look like this. Okay, so when we express it in polar form, let's write it out this way. R equals the square root of a squared plus b squared, and theta equals the inverse tangent of b over a. It's the y guy over the x guy. Okay, so that's what we're going to do. We're going to find r, find theta, then we'll be able to plug it into z. So let's write our z up here equals r cos theta plus I sine theta. We want to find r equals the square root 9 squared plus 7 squared equals square root 81 plus 49 equals square root 130. Okay, so let's find theta equals the tangent, inverse tangent of 7 divided by 9. Okay, and you're just going to go crunch it in a calculator. Let's find a calculator, crunch it in. So let's go find the arctangent, because in this calculator it's arctangent. And depending on if you want to be in degrees or radians, let's go for degrees. Arctangent 7 divided by 9. That's going to be 37.9 degrees. And then what we're going to do is we're going to write it in our polar form. Equals square root 130 cosine 37.9 degrees plus I sine 37.9 degrees. Alrighty, so that's how we do polar form. Let's work the next problem. Now just real quick, let's identify where this is. 1, 2, down 2. Okay, so our tangent is going to be in a different location. So we have z equals r cosine theta plus I sine theta. Come over here and look at our rules. Let's go find our rules over here. This particular one, our a is -2, so we're going to be working, whoops, let's draw on this one too. Going to be working on this one. Because a is -2, we're going to add pi to the angle that we find. So let's come and let's work our problem. So let's find r equals the square root of -2 squared plus -2 squared. So that equals square root of 8. And that's going to be 2 square root 2. Let's find theta. Theta equals inverse tangent -2 divided by -2. And when we're done, we're going to add pi, which we're going to add 180. I don't care if you work in radians or degrees. It's easier for me to work in degrees, and so that's the reason why I'm doing it. So let's just go to our cool calculator. Let's do arctangent of -2 divided by -2. And that is 45 degrees. So we have 45 degrees plus 180. And it didn't write for you anyway, and so let's try again. Back. Oh, this is 180. So 45 theta equals 45 degrees plus 180. So it's 225. Oh, and it all disappeared. Oh, guys, I'm getting mad. Next year, I'm so doing this differently. So let's plug everything in. Okay, so that is what our z equals. Sweet. Okay, so we want to graph it, and then we're going to express it in rectangular form. So in other words, we're working on this first one. We're going to then have a plus bi. So let's graph it. Let's go 3 pi fourths, which is on this line. And we're going to go out 5. So that's 1, 2, 3, 4, 5. So that's the graph of the complex number on a polar grid. So this is easy-ish, okay? So let's go find our table. And then on our table, we're going to look at 3 pi fourths. Okay, so this is the sine, it's cosine. So let's come back over to the board. We can remember that. So we have 5, and we're just substituting. 5 cosine of 3 pi fourths cosine of 3 pi fourths is square root of 2. Nope, that's the sine. Cosine is negative square root of 2 over 2. This thing is not keeping writing, and it's oh so annoying. Now we're going to add I, and then this one's positive square root 2 over 2. Distribute the 5, so we get negative 5 square root 2 over 2 plus 5 square root 2 over 2 I. Okay, now the placement of the I is sort of important. When I'm dealing with sine and cosine, we put it in front of it because we don't want you to think that the operation belongs inside the sine function. Okay, but otherwise we'll put it behind our numbers. Once we have our numbers and there's no longer sines or cosines, then we'll put it behind our numbers. Very interesting. Very interesting. Okay, so now let's work on the second problem. Let's go to 5 pi thirds, which is right here. It's on this line. Now we're going to go out 4. 1, 2, 3, 4. Okay, so with that same information, let's come back to this other one. Now let's go find our 5 pi thirds. And this is our sine, this is our cosine. So we can remember since I cover it up. And then we're just going to substitute stuff in. So I have 4, and my cosine of 5 pi thirds is 1/2. Can you guys just see stuff just disappears? Plus I, and the sine of 5 pi thirds is negative square root 3 over 2. So we're just going to distribute. So this becomes 2 plus 2 square root 3. That wasn't a plus at all, that was a minus. Minus 2 square root 3 I. That's our answer. Alright, so here's the rules. It's hard for me to know which one to go back to. This rules, I like these rules because when I multiply two complex numbers together, then what I do is I multiply their r's, but I add their angles. So when we multiply, we usually get bigger in theory. It's not always true. When I divide them, I divide my r's and I subtract my thetas. Subtract my angles. Angle 1 minus angle 2. First one minus the second one. Okay, so let's go and let's work this problem. It's kind of easy-ish. Let's go find the notes for it. And we'll use the notes here. So my r's, we're not going to work this one. My r's are going to be, we're multiplying them, so it's 3 times 5. This is okay, so I've written 5 6 different times. Let me just delete this thing and see if it's starting to, oh, there it shows up. Okay, so 3 times 5. Now we're going to do cosine. It's not going to write for me, because I so need to find something else that works. Guys, I probably already worked it out without my help, huh? Okay, and then what we're going to do is we're going to go ahead and add these fractions. So pi thirds can be written as 4 pi twelfths plus pi fourths can be written as 3 pi twelfths. So when we add them together, we get 7 pi twelfths. So then we have 15 cosine 7 pi twelfths plus I sine 7 pi twelfths. Now if you want to, you can do those adding whatever matiggers, but I'm not going to. I'm just going to go ahead and use a calculator. Make sure you're calculating this particular problem is in radians. So we're going to go ahead, click to radians, and let's do cosine 7 pi, I'm just typing pi, divided by, whoops, that's not where I want the divide by. Let's go back, parentheses, 7 pi divided by 12. There we go. So this is 15 times negative 0.2588 plus, let's do sine. The reason why I like this one is I can just come and type sine. Sweet! I 0.9657. It's not 57, it's 59. Okay, let's come back over here and let's look. And then what I want to do is I want to distribute the 15 through. So I'm just going to come over here and use my cool calculator and put a 15 in front. So this becomes 14.49 I. And then let's put a cosine. And this will be minus, 3.88 plus 14 point, I can't remember what it was, my stuff deleted it. 14.49. I. So this is our answer. Cool, huh? Okay, that's good. Let's go to the next problem. Let's go to the next rules. Okay, so if we're going to be raising stuff to power, to an nth degree, then we're going to take our r and raise it to the nth degree, and our angles we're going to multiply by n. That so didn't even show up. Oh well, let's write it over here. Oh, that's why it didn't show up. I was writing on the wrong board. All right, so let's work that problem with this in mind. So we're not going to work that one. You can work that one on your own. If I have all this stuff, first thing we want to do is we want to find r. And we want to find theta. So r equals the square root 1 squared plus square root 3 squared, which is square root 4, which is 2. Theta equals tangent inverse of square root 3 over 1. Let's go to desmos.com and find out what that angle is. Let's go to degrees again. It's easier for me to work in degrees, so let's get rid of that sucker. Let's do tangent. I wonder if this will work. Tangent up arrow 1, negative 1. I don't know if it will. Square root 3. It did! Cool, I didn't have to use arctangent, but I could have, I just didn't have to. So theta equals 60 degrees. And we'll leave it there. Okay, so now I have my z, let's write z, z equals 2 cosine 60 plus I sine 60. Okay, and when we raise it to the 4th power, we're going to insert a 4 in all those locations. So this becomes 16 cosine, what's 4 times 60? 240, plus I sine 240. And then we're going to go use our trig chart. Here's my trig chart. And what did we say it was? 240, cosine 240. This is my sine and this is my cosine. So cosine of 240 is negative 1/2 plus sine of 240 is negative square root 3 over 2. And then we're going to distribute. So negative 8 minus 8 square root 3 I. Cool. That's how you do it. All right. So when we're looking for the nth root, this one's a little bit trickier. Just a little bit. So let's go find our rules. When we're looking for the nth root, this is the part that's important. We have to crunch those numbers as many times less than n as we want. Less than p. So if we're looking for the cubed root, then we're going to put in a 0, 1, and 2, not 3, because p minus 1 would be 2. Okay, so let's go work on a problem. And we're not going to do that one, because this will give us enough fun. Okay, so first off, what we have to do is we have to find r, and we have to find theta. I think we already found r, but we'll do it again. Square root 2 squared plus 2 squared. Square root 8. And we're going to leave it like that. I know sometimes I write things in better form. And we're going to do tangent, inverse. All right, we're going to start this one over. Let's find theta. So using our cool graphing calculator, we're going to go ahead and do inverse tangent of 2 divided by 2. It's going to give us 45 degrees. So theta equals 45 degrees. So we're looking for the cubed root. So let's write our z though. Equals r square root of 8. And then we're going to do cosine 45 degrees. Okay, so we just remember square root of 8 and 45 degrees. By the way, I've written this 5 different times and it's not writing. I'm about done with this format. Okay, so if we want to take the cubed root of it, cubed root is the same thing as putting stuff to the 1/3 power. Okay, because over here, oh, I'm on the wrong rule. Over here you see it shows 2 pi n. 2 pi is the same as 360, so we're going to work that. So for n equals 0, then we get the cubed root of z equals 8 to the 1/2 power, which is a square root power, to the 1/3 power is 8 to the 1/6 power. Cosine 15 degrees. Plus I sine this is annoying. Okay, so we're going to go plug this into our calculator. We're going to do this and that. You ready? Let's watch. How do we do that in our calculator? We're going to take 8, up arrow, 1 divided by 6, go out, so I'm going to use an arrow on the outside. Then we're going to do cosine 15. We're going to do 8, up arrow, 1 divided by 6, go out, sine 15. Sweet. So this becomes 1.37 plus 0. This isn't even writing, guys. It's really frustrating. .37 plus 0.37i. Didn't even write what I just did. So that is our first answer. It's for n equals 0. Now we're going to do n equals 1. For n equals 1, we're still going to get 8 to the 1/6 power. But then we're going to get cosine 45 plus 360 divided by 3 plus I sine 120, 135. Okay, when I crunch my numbers, that's what I get when I take 45 plus 360 divided by 3. I get 135. So let's go to our calculator. The only thing we have to change is the angle, so that's 135. So this becomes -1 plus 1i. Oh, it wrote it. Nice. Okay, and we have to rework this problem one more time for n equals 2. So let's go ahead and use this board over here for n equals 2. For n equals 2, we still have 8 to the 1/6 power it's a 6 darn thing. And we're going to do cosine 45 plus 360 times 2 all over 3. Let's go find out what that is. 45, whoops, do parentheses. 45 plus 720 divided by 3. 225. Plus I sine 225. Okay, and we're going to go ahead and use, oh, we can't. Yes, we can. Let's go find our table. Whoa, come back. Our table for 225. Oh, we can, but we don't need to. So this is our sine and this is our cosine. But we're going to go ahead and plug it into here because that's easier. 225 for my cosine, 225 for my sine. -1, -1. And then, oh, okay, back up. So then this becomes -1 minus 1i. So when that is 2. Whoa, didn't even write it. Still didn't write it. -1 minus 1i. I think we're done. We are. Alright guys, see you later.